What exists outside the edge of the universe? What's outside the universe? Here's the fast truth. Cosmologists will tell you the universe has no edge, no wall, and it isn't expanding into anything. So why does the question feel so compelling? Because the real edge isn't a place. It's a horizon in time. Our limits aren't physical barriers. They're boundaries set by the speed of light and by the way space itself expands. And those boundaries shift. Some horizons grow. Others trap information forever. That's the map. Now let's walk it. The part we can actually see, the observable universe, is about 93 billion light-years across. That number is far larger than the age of the universe, because while light was traveling to us, space itself was stretching, making the distances bigger. We don't see past a wall. We stop where light hasn't had enough time to reach us. Think of standing in a dark field with a lantern. Your circle of visibility grows with time. The darkness beyond isn't empty, it's just unreached. So when we ask, what's beyond the edge? What we're really asking is, what exists beyond the region light has reached us from so far? And the answer could be a lot more universe, maybe finite but unbounded, maybe infinite, maybe something even stranger. But before speculation, let's get the boundaries straight. First, the particle horizon. This is the limit of what we can see right now. It sets the radius of the observable universe at about 46.5 billion light-years. Remember, that's the distance today, stretched by expansion, not just the travel time of the light. Second, the Hubble sphere. This is the distance where expansion pulls galaxies away at exactly the speed of light. It's around 14 billion light-years. Beyond that, galaxies recede faster than light, but that's allowed because relativity only forbids things from moving faster through space, not space itself stretching. Third, the cosmic event horizon. This is the limit of what we will ever see from light emitted today. It's about 16 to 18 billion light-years. Anything farther is already lost to us forever. And here's the paradox. The particle horizon is 46 billion light-years, but the event horizon is only around 16 to 18. That means we are looking at galaxies so distant and moving so fast that any light they send out today will never reach us. We are watching their ancient glow, while their present and their future are already gone from our reach. Expansion doesn't need an outside. Space isn't spreading into a bigger box. Space itself is stretching. People often use the balloon analogy. Dots on a balloon's surface move apart as the balloon inflates. Helpful, but also misleading. Because the balloon expands into the room. That makes us imagine our universe expanding into something larger. That's not how it works. A better picture is a haunted hotel hallway. Imagine doors on both sides. The carpet and walls slowly stretch, so the distance between doors increases. No outside room, just more hallway appearing in between. That's how space expands. And here's the crucial point, there's no center. The Big Bang wasn't an explosion from one spot. It was everywhere at once. Every galaxy sees every other galaxy moving away. And any observer, anywhere, would see the same thing. Two main options. One, finite but unbounded, like Earth's surface. You can walk forever and never fall off an edge, yet the total surface area is finite because it loops back on itself. Two, truly infinite. Evidence from the cosmic microwave background shows the universe is very flat. Flatness is exactly what you'd expect in an infinite cosmos, or in one so huge we can't detect its curve. Either way, there's no edge, no wall, no outside, just geometry. Here's the bittersweet part. Our observable bubble keeps growing as ancient photons arrive. But the event horizon means many galaxies we see right now will eventually fade away forever. Their light gets stretched, dimmed, and then lost. We're living in a window where the sky shows us both relics of the past and futures we'll never witness. If this is making the universe feel stranger, but also clearer, stick with me. Next, we'll leave the firm ground of observation and step into speculation. Bubble universes, holograms, and even true nothingness. If you want more videos that separate what's known from what's possible, hit subscribe so you don't miss what's coming. Inflation explains the smoothness of our universe. But some versions say it never ended everywhere. Instead, it keeps bubbling off new universes like cosmic popcorn. Each bubble could have different physics. One might never form stars. Another might have conditions more favorable to life than ours. The problem is obvious. If every possible universe exists somewhere, how do we make predictions? If everything happens, the theory risks explaining nothing. The modern twist is this. Newer ideas use the holographic principle, the notion that information lives on surfaces, to suggest the multiverse might not be infinite chaos. Instead, it could be trimmed down to a manageable family of possible universes. Ones we might test by studying gravitational waves or faint relics in the cosmic background. String theory imagines our universe as a three-dimensional brain, floating in a higher dimensional bulk. Other brains could exist, close but unreachable. Some versions even say the Big Bang was two brains colliding, releasing energy that became our hot, early universe. Think of it like sheets of paper brushing together in a hidden stack of dimensions. Some models say the Big Bang was not a beginning, but a bounce. In that picture, there's a mirror universe on the other side of time where the arrow of time flows the opposite way. In our universe, glasses fall and shatter. In theirs, shards leap up and reform the glass. A simple way to say it, their future looks like our past. Black holes taught us that information depends on surface area, not volume. If you take that seriously, you get the holographic principle. Our entire three-dimensional reality might be the projection of information written on a two-dimensional boundary. Think of a credit card hologram. A flat surface contains the full depth of an image. If the principle is right, our universe is like that. What feels three-dimensional is really a projection of information coded at the horizon of space. And then there's the starkest idea of all. Maybe beyond the horizon, there's not space, not darkness, just nothing. No dimensions, no time, no physics. Hard to even picture. Because the moment you try to imagine nothing, you've already turned it into something. But this may be the closest thing we have to a true edge. Even if we never cross these horizons, science isn't stuck. Every sharper map of the cosmic background, every new gravitational wave detection, gives us tighter constraints on what's possible. Horizons may limit what we see, but not what we can infer. So what exists outside the edge? Maybe more of the same? Maybe other universes? Maybe a hidden code? Maybe nothing at all? The edge isn't a wall. It's a line drawn by time, by light speed, and by expansion. The universe may not give us an outside to touch, but it gives us a frontier to understand. If this video helped you understand the universe a little better, please consider subscribing, and we will see you in the next video.